Here we go. Let's take a look at the last part of 16.1, and it's all review from Chemistry 20. We still have pH and pOH calculations. Please take a look at 7.16 and 7.17. I'm not going to do a zillion of these for you and turn this into a 7-video lesson. This is a core skill that I expect you guys to know from Chemistry 20. So make sure you're reading the textbook, make sure you're practicing, look at the couple of examples here, and we will go forward from there. So here is your repertoire of moving between all of that information that you had between pH, pOH, log values, hydronium hydroxide, standard mole per liter concentration values. There's your pH and pOH equilibrium, and we just equated it to the equilibrium constant right there that we had with the last few examples. Okay, there was one issue between log values and standard notation or scientific notation values with how we took a look at significant digits. Please, guys, don't let this mess you up. The only new rule we are learning and have learned in the last course was that sig-dig rules looked a little different for pH and pOH. Okay, take a look at the neutral solutions on this chart. Okay, if we take a look at a neutral solution, it makes sense that the pH is a value of 7. Notice that that number is to the left of the decimal place. We say that any digit to the left in a pH or pOH value only is insignificant. So, if I had a pH of 7, I expect water to be neutral to have equal and balanced parts of hydronium and hydroxide. So a pH of 7 has a hydronium ion concentration of 10 to the negative 7. Note the 7s. Okay, well, in a neutral solution, hydronium should balance hydroxide. So there you go, and your hydroxide ion concentration is 10 to the negative 7. Okay, so the 7s are kind of uniform here, and they make sense to us. They really do. And as we look at it, we remember that in scientific notation, the exponents here and here were not significant digits. They just told us where the decimal is. So in a log value, the numbers to the left of the decimal just happen to tell us where the decimal point is. Okay, now think about where your measurement is. In a scientific notation number, sig-digs only ever came from the coefficient. There's 2 sig-digs. If we looked at hydroxide ion concentration, it still, being a standard scientific notation number, would only come from the coefficient, and there's 2 sig-digs. So, if numbers to the right of the decimal place are the significant digits in pH and pOH values, then there should be 2 points after the decimal for pH and pOH. Okay, I hope that refreshes your memory on where those sig-dig rules come from. I know a lot of kids got frustrated with it in Chemistry 20, but you just got to slow down, realize where this is coming from. Now, you guys have done more logarithmic stuff since you're taking Math 30 or have taken Math 30, and so we should realize some of this a little bit better now instead of teaching it out of order way back when in Chem 20. But pay attention to that one, okay? As we take a look at a couple of examples here, I'm going to do just a couple for you since the answers are on the next page. And what we're going to do is look at these ones here and kind of go through it step by step on the calculator. So we're starting with a pH value of 3. Okay, pH value of 3. Do you see where the decimal point would be with a whole number of 3? Of course you do. You see it right here just after the decimal, or just after the 3. Are there any digits to the right of the decimal place? No, there are not. It's just a whole number, so kind of an oddity. that we see with pH and pOH values is dealing with things that have 0 sig digs. Now, this won't come up on too many quizzes or tests or anything like that, but it is still a possibility when we're just looking at magnitudes of acidity or basicity and not looking for an actual measurement. So, you have a pH of 3. Where should we go next? This is an open-ended question. What should we go look for? You have a couple of choices. Remember that pH does lead you to hydronium ion concentrations, and pH with the constants of 4 does lead you to a pOH. So either one of these things could be figured out pretty quickly. If we want to figure out the pOH, we can do that. I'll put the calculator right here. Yeah, maybe over here. Okay, and so if the pH is 3 and pH plus pOH is equal to 14, then 14 minus the pH of 3 gives us a pOH of 11. Again, no digits after that decimal point because we had 0 sig digs to begin with. We can't create any for pOH. The other place we would have gone is to hydronium ion concentration. Now your calculator is going to struggle with this a little bit with a 0 sig dig problem, but remember that your formula up here, hydronium concentration is equal just to base 10 raised to the negative pH. And so there's your 10, use your little hat button, negative pH of 3, and we do this and we get 0.001. Okay, that's great, but that's one significant digit. We can't really state that, so move your decimal 3 places, 1, 2, 3, and you get 10 to the negative 3. No coefficient because no sig digs. I know, the no sig digs are weird, but you'll see them in the textbook examples. If you're having troubles with that, you take a look at our pH scale, look at the pH of 3 here. If we ignore the sig digs, then it's just 10 to the negative 3 here, and we ignore the sig digs. Okay, so using that logic then, if 3 is equal to 10 to the negative 3 with no sig digs, then 11 should be 10 to the negative 11. pH of 3 is acidic, therefore expect very small concentrations of hydroxide. Okay, pretty easy one there. It's just the weirdness of the 0 sig digs. Most of the ones we're going to give you are going to have some amount of significant digits, so please pay close attention to them. There will be questions on the quiz or the test online that will test you on sig digs if you're paying attention. So here we go. You have a pOH of 6.1. How many significant digits here? This is a logarithmic value of pOH, so only numbers to the right of the decimal place count, so you have a 1 sig dig answer. Bear this in mind when we start calculating out similar values. If I have a pOH of 6.1, I can go figure out my hydroxide ion concentration. Hydroxide is equal to 10 to the negative pOH. Okay, we can go do that. And so my hydroxide ion concentration is 10 raised to the power of negative 6.1, and plunk that through, and you get 7.943 times 10 to the negative 7. How many of these significant digits are you allowed? Only one. The first number to be dropped is the one that determines your rounding. So this must be 8 times 10 to the negative 7. We can use this pOH value to figure out a pH, since pH plus pOH are equal to 14. Subtract that pOH from 14, and the remainder will be the pH value. 14 minus 6.1 gives us, obviously, 7.9, which is still a 1 sig dig answer. And now we just have to do our hydronium to pH conversion. And so 10 raised to the power of 7.9. Oops, what did I forget? You're right, I forgot the negative. 10 raised to the power of the negative 7.9. There we go. gives us 1.25 times 10 to the negative 8. The 2 would round us down. The 1 is the single significant digit. So 1 times 10 to the negative 8. And you can see you have a greater concentration of hydroxide than hydronium. Okay, so there's 2 guided examples for you. You can finish the table. Don't turn the page in your notes. Oh, too late. You can see all of your answers here, so you can match that information. All right, number 2, again, has a little bit more of an involved question, maybe involving the dissociation of NaOH. And so see if you guys can solve that one. The answer is provided. Yeah, I know you guys would like to have more answers here, but perhaps if I leave more of them away, a few more of you guys will start checking into our tutorial sessions on Wednesday afternoons. Okay, so do your best with it. If it all works out, I guess I won't see you Wednesday. And try a few questions on page 718 and see if you guys can just reinforce this Chem 20 concept. All right, we'll move on to the other parts of the chapter in the next lessons, but this finishes 16.1. Good luck with it, guys, and yeah, don't forget about those tutorial sessions. It'd be nice to see your bright, shiny faces.